Thank you very much, Lenny. And before I get going, my disclosures, I'm a former employee of Illumina, and I'm a current stockholder of Illumina, which is the company that makes the next generation sequencing technology that takes part in my story. That said, I'm not here to talk about my former employer, my current employer, or even my professional life. I'm here to tell you a story from my personal life. I should also say a disclaimer that I am not talking about AYA, because this is a story about my mother. That said, AYA is fundamentally a story about rare cancer, and so is my story. So if I have one goal today, it's just to give everybody in this room a refreshed appreciation for the wonderful work you do. You chose the right career, and I think my story is a wonderful demonstration of that fact. So my story. In 2003, my mother developed an itchy rash that just wouldn't go away. She went from doctor to doctor to doctor trying to find relief. They told her it was everything under the sun, from soap allergies to skin mites to tropical disease to nerves. And the only consistency was that no diagnosis stuck, and nothing they gave her offered any permanent relief. So it went on for this, on and on and on, and finally, 2 years into her suffering, she finally got her answer through a community dermatologist near her home in Lexington, Kentucky. This gentleman in medical school had studied cutaneous T-cell lymphomas, and it turned out she had an extraordinarily rare form of CTCL, known as Sézary syndrome. And when I say rare, the disease strikes about 50 new Americans per year. And by contrast, about 400 Americans get struck by lightning each year. Not even a lightning strike. So while the certainty offered some relief, the news was very bad. There was no treatment that was shown to increase 5-year survival. She was given a stage 4 diagnosis, and she was told she could expect to live for about 18 months. She was a fighter, was always a fighter, and she found some of the best specialists in the world, and through just exquisite application of the standard of care, they allowed her to live for much longer than her initial prognosis. At that time, I was a scientist leading a research team at Illumina. I had my life immersed in genomics. However, it never occurred to me to apply what I was doing in my professional life to my mother. When she was diagnosed, sequencing a genome cost about $20 million. To do the work I'm going to describe for you in my talk, it would have cost about $50 million. So it wasn't like I thought of it and it just seemed unreachable at that time. It didn't even occur to me because it was so remote. However, the period over which she lived, or over which she had her disease, coincided with a plot that Dr. Adamson showed us in his talk just before mine. It's that moment in 2007 where the bottom falls out of the cost of doing genomic sequencing. And even as that was happening, and even as I kind of had a front row seat to that, still did not occur to me. And then in 2009, I was at a next generation sequencing meeting. This was a technical meeting, was not a medical meeting. I was sitting in an audience much like the one you guys are sitting in right now. and I saw presented the very first case of a cancer patient where that patient's tumor was sequenced in their own lifetime with the intent of identifying the driver mutations, and if they got lucky, to identify routes for interfering with those drivers to see if you could repurpose a drug to treat that patient's rare disease. It was a 70-year-old physician who had an adenocarcinoma of the tongue. And you can imagine me as a son of a rare cancer patient sitting in that audience. It was a presentation by Dr. Mark O'Mara from the University of British Columbia, and he showed the before and after scans from this rare cancer patient, and I saw those tumors shrink after the application of the drug that they discovered could be repurposed based on that patient's genome. And my immediate thought was, that's my mother he's talking about. So at that moment, I had a new purpose in life. I was going to see if I could do that, what I had just seen at this meeting, to my own mother. It didn't quite go as quickly as you might think. Although I was sitting about 30 feet away from what then was the only CLIA laboratory that did next-generation sequencing, it went in fits and starts. I tried to keep my day job. I tried to organize my mother's physicians from almost a continent away, and I found the going very difficult. So fortunately, my mother's disease was under pretty stable control from a drug that her doctor had her on. So the idea was I would kind of putter along with this back burner project. We'd eventually maybe find something, and when my mom's drug failed, as we expected it to do eventually, then we would have something in our back pocket, hopefully, to give to her. Well, it went on like that for more than a year, and then in the summer of 2010, life intervened. My mother's drug started to fail, and a tumor popped up on her right leg. They zapped it with radiation, it went away, and about 2 months later, another tumor popped up. They zapped that one, and before long, 2 more came up. And eventually, it was obvious that we weren't going to be able to control this with radiation. Eventually, they started popping up at a rate of about 1 or 2 new tumors per day. The disease got wildly out of control, and it became clear if I didn't pick up the pace that she was going to die before we ever learned if my technology could help her. So in the December of 2010, I went on a leave of absence from my job. I moved from San Diego with my wife and our 3 children who were all in the first grade, and we relocated to Lexington, Kentucky, where my parents lived, and I repurposed a second-story farmhouse bedroom to be the command central for a genome project for my mother. First order of business was to organize the physicians in her local area. I found some like-minded people, Dr. Fernando de Castro, the doctor who had given her diagnosis 5 years previous, was kind of my co-conspirator. And through a chain of introductions that started from Dr. de Castro, I eventually wound up with Dr. Alex Sekulik at the Mayo Clinic in Scottsdale, Arizona, and he introduced me to Drs. David Craig and John Carpton at the Translational Genetics Research Institute, or TGen, a nonprofit there in Phoenix. And this became my volunteer team. We sequenced both her genomic DNA as well as the RNA from 2 of her tumors. And when the sequencing came off of the machines, Drs. Carpton and Craig found something quite remarkable. On chromosome 2, there was about 140 kilobases that was amplified. They looked more closely at what was within this amplified region, and it was two genes, CD28 and CTLA4. I want to remind everybody that this was a cutaneous T-cell lymphoma. What are CD28 and CTLA4? They're none other than two of the most important regulators of T-cell proliferation when a T-cell is activated in the midst of an immune response. And this is the closest we're going to get to PowerPoint slides right here. So both of these molecules are transmembrane receptor proteins. They have an extracellular domain that senses signals in the cell's environment, and an intracellular domain that sends signals to the rest of the cell when the signals are sensed by the extracellular domain. CD28 is the stimulator of T-cell proliferation. CTLA4 its transcription is activated when CD28 senses its signals. It's expressed on the cell membrane, and it opposes the effects of CD28. So CD28 is the gas pedal, CTLA4 is the brakes, and it's the balanced activity of these two receptor proteins that keeps the immune response in check and keeps T-cell proliferation in check. What Drs. Craig and Carpton found was that the genes for these proteins weren't just amplified, but they were fused, and the fusion was quite remarkable. It was the extracellular sensing domain of CTLA4 was fused in frame to the intracellular signaling domain of CD28. We had RNA data, so we showed that this was abundantly expressed. It was in the top 90th percentile of all expressed proteins, and it was properly spliced, and it was in frame. And so, in other words, the genome had shown that the brake pedal had been rewired to the acceleration. And so it would seem to explain the biology of this tumor, that when the cell was sensing that it was time to stop growing, instead the signal that was being sent was to keep proliferating. Fascinating biology, but what do you do with it? Well, I'm not making this up. 6 days before the cancer genome was completed, the FDA approved a drug, ipilimumab, a monoclonal antibody drug, that binds to the extracellular sensing domain of CTLA4. And in melanoma, where this is applied to normal T cells, you jam up the brake pedal, the car keeps rolling, it stimulates the proliferation of T cells, and that little boost of the immune system can enhance the survival of many melanoma patients. Now, if you didn't know about this reverse circuitry that we found in my mother's genome, that was implied by my mother's genome, this is the last drug you would ever give to a patient with a T-cell lymphoma, right? It would be gasoline thrown onto the fire. But the genomic data, the RNA data, everything was pointing to this mechanism, and that this drug would be predicted to have the opposite effect on her cancerous T cells as it would on normal T cells. So Dr. Sekulik was able to convince my mother's oncologist, a community oncologist named Dr. John Goman. He practiced at Central Baptist Hospital in Lexington, Kentucky. Dr. Sekulik convinced him of the scientific case, and on July 30th, 2011, my mother had her first infusion. The second most dramatic point in this whole story is 1 week after her infusion. She had her 1 week checkup with Dr. Goman. She walks into the clinic and he can immediately see a difference. At this advanced stage of this disease, you're red as a lobster. Anyone on the street can see the patient and immediately see that they're sick. As my mother walked into Dr. Goman's office, she was now a more healthy pink color. He approached her, and her lymph nodes, since her diagnosis 5 years previous, had been so swollen it was visible to the naked eye. He palpates her lymph nodes, and they've gone down to the point where he can't feel them. Dr. Goman is a big bear of a man. He grabs my mother, gives her a big hug, swings her across the office, and tells her she's going to make her son's company famous. I think for all he knew, Illumina was me and two guys with a machine in the corner, and he thought this was going to be really big stuff, our big break. Within 2 weeks, she had very large ulcerated tumors on her legs. Within 2 weeks, those tumors started healing up to the point where many of them were closing. And even more remarkable than these physical signs was what was happening just in my mother's life. She had gone from being sofa-bound, never getting out of the house except to see doctors, spending all day watching TV, and she started living again. She started going to restaurants, to movies, what was just always out with friends. And in fact, I'm not making this up, she stopped returning my phone calls. Every time I reached her, she was just out drinking in life again. And it was just breathtaking how when you have something that can stop the cancer in its tracks, how quickly the body is able to heal itself. And it was just fantastic as a son to see this renaissance in my mother's life. Now, as is too often the case with molecularly targeted drugs, it did not take long for the cancer to find a way around the treatment. Within 2 months, the tumor started coming back. We sequenced her tumors again. There was nothing in the recurrent ones that would explain how it had gotten around the drug. All the original mutations were there. There were no obvious new mutations present. And the disease came back with a vengeance. And on November 30th of that year, my mother passed away. Despite that tragic outcome, I feel like the luckiest person on earth. I could live 10 lifetimes and never have the privilege of seeing the work that I had just kind of been on a random walk. I thought sequencing was cool and wasn't particularly doing it for the sake of cancer or human health. To see that effect in my mother right at the dawn when this was becoming practicable was just the greatest gift anybody could ever receive. I had mentioned to all of you that the second most dramatic point in this story. Let me tell you the most dramatic moment. Almost precisely a month after she started her infusions, September 2nd of 2011, when my mother was at the peak of her health, it was my mom and dad's 50th wedding anniversary. And so instead of being there on that sofa, holed up in front of that TV, she was out in a nice inn in the middle of horse country, drinking iced tea with my dad, and looking back on 50 beautiful years together, and looking forward to what at that moment they hoped would be many more years together, but obviously that wasn't to be the case. She demonstrates the promise of what might be hidden in any patient's genome. She also demonstrates the benefit, but also the challenge of being the index patient. Her doctors gave her had no idea what the appropriate doses were, so they gave her the dosing and scheduling that was for melanoma. Was that the right one for her disease? Who knows? And I suppose it will take other patients, if we should find the same lesion in their tumor, and other bold doctors to find out what the right way to do this is. So as I look back on my experiences, what I draw from it is that the internet and the genome give us the power to connect any relevant piece of science to the individual patient. What we need now is a broader population of medical professionals who are trained in how to harvest that information and apply it to the patient before them. We also need better ways of collecting and storing the individual experiences, such as my mother's, so that they're readily available to help the next patient. So if I can distill my message into 2 words, it's this: it's thank you. As I look out on this audience, I see those scientists who many years ago were doing the work on CTLA-4 and CD28, who had no idea that they were working on Sézary syndrome, but who are my unwitting collaborators as I got to add a little bit of life to my mother. I look out at the doctors here, and what I see are the people who, with the utmost sensitivity, gave my family the worst news we would ever hear, who danced with us through our victories, and then who held my mother's hand as she was dying. And I thank you. I see bright minds. I see big hearts. I see strong wills that are up to the challenges that history has put before us. And I thank you, and I, for one, feel like the luckiest person alive. Thank you, everybody, for your time.